New York City Bobby here with a quick update on the RC Single Scull boat I made. I posted a video about it a few weeks back. I made some improvements. I took the boat back to Central Park's model boating pond to see how well the improvements went, and I think overall the testing went fairly well. At low to medium speed, the boat performs quite well and I'm happy with it. At higher speeds, you'll see that the timing gets off on the rowing mechanism, and what happens is the oars enter the water too late in the power stroke, so you're losing quite a lot of the power stroke. In order to fix this, I really need to bring my laptop with me next time I go testing so I can change the code. It's very hard to estimate exactly where the water line is and get it just right without being actually there in the water with the boat and changing some of the parameters. So that's something I'll do in the future. The worst situation really for me is that I'm still lugging around this gigantic center board weight, which weighs well over a kilogram. And I had talked about possibly redesigning the boat to be a catamaran, where you would have a sponson under each let's say oar lock. That would give you the stability, and I think that would really be a good design. However, it's a lot of work to build two sponsons and change the design up. I'm also considering the easier and lazier approach of putting a float under each oar lock now and turning this into a trimaran. Now that would give you the stability. However, you still have the issue that the water line has to be around 1 inch from the top of this boat in order for the mechanism to work. This hull, it displaces so much water, it will still need a lot of weight to bring the water line to the right height. However, that weight could be distributed inside the hull, and I could get rid of this thing, which I do think would be a major improvement. So those are some possibilities in the future. But let me talk to you about the improvements I made, and I'll show you footage of how the test went. Another change I made to the boat was I created a second mount for the oar lock closer to the boat hull. So you can either put the oar lock in this position or in this position. As you bring the oar lock closer to the hull, it actually forces the oar to go deeper into the water and come out further when it's doing the feathering stroke. So you kind of get both changes at the same time, and I think I needed that. That's why I had put it in. Perhaps I would have been better off moving it even a little bit closer in. Well, one of the big improvements I made to the boat was changing the oar lock situation. If you saw my first video, you would have noticed that the oars were actually slipping out of these oar locks. So now I have 3D printed this. It rotates in this direction. It gives you one of the degrees of freedom, and it also swivels this way. That gives you the second degree of freedom. And then I have these locking collars. Once the oar is in, it can also rotate. So once again, the oar goes into the oar lock like this. The two collars allow for rotation. It swivels up and down, and it also moves left and right. So you get those 3 degrees of rotation, which are necessary for the oar movement. That was a big improvement. Another improvement I made was when I originally tested the boat, I was unable to read the throttle position from my remote control receiver. So what I did was I made this little servo that was attached to a potentiometer, and I attached that servo to the throttle joystick. So when I moved that, it basically changed this potentiometer, and I had the Arduino read the potentiometer. Turns out it's super easy to plug the output of your receiver directly into the Arduino and figure out what the pulse width is. That's just like one line of code. So this entire unit got dropped out. A second improvement I had planned to do was to replace the Arduino Uno with a Nano. I bought a off-market Nano, I think from Banggood or AliExpress. Was unable to get good communication with my computer. It kept dropping in and out. So I was unable to get this guy to work, which is crazy, stupid, but I had to stick with the Uno. So another improvement I wanted to do on this boat was to make it be able to run off of a 3S cell. My previous speed controller was a very cheesy speed controller. It only went up to 2S. So after a little research, I bought one of these It's called a Quick Run 1060. A lot of people swear by this thing. They say it's a really good speed controller. My problem is it kept dropping out of being able to link up with my radio. Sometimes I would turn it on and everything was good, and sometimes it wasn't. I just could not deal with it. So I went kind of back to an old reliable. Sitting in my boat is a speed controller called a Victor 884. If you've done First Robotics over the years like I did, we used to use these speed controllers all the time. They're really, big industrial sort of speed controllers, can handle a lot of current, maybe 40 or more amps. So it's overkill for this project, but it always links up with my radio and never gives me any problems. Also, on top of it is one of those DC buck converters that's converting the 3S into 5 volts. Another kind of major improvement I made to this whole mechanism was I put limit switches at the end of the travel on both sides. And now if I make a software mistake, which I do all the time, and my this shuttle piece which goes left and right, if it slams into the end stops, it will now shut down, and I don't have to worry about causing any huge damage. That was something I hadn't done, and it was just killing me.